Okay, in the examples we're going to be looking at today, we're going to be finding common factors of expressions. In the first step, we just look for the greatest common factor. In some of the later examples, we look at actually factoring them out. So when you have an expression like this one here, in this case we have a trinomial, there's 3 terms. We want to look for a value that we can pull out of each term or factor out of each term. So if you look at the first term, we have 2x cubed y plus 4x squared y squared minus 2x squared y. Now each one of those terms has the common factor of 2, which means that 2 can be divided evenly into each term. So one of the common factors, or the numerical common factor, would be 2. Then we have x cubed, x squared, and x squared. So if we look at just the x's first, each one of those terms has at least x times x, or x squared. So that means we can factor an x squared out of each term. Then the last term, or the last part of the term, sorry, is the y's. So we have a y, we have a y squared, and we have a y. So in each term, we have at least a y, so we would be able to factor out a y. Now in this question, they're not asking us to actually factor this expression. They're just asking us to find the greatest common factor. So this would be the greatest common factor for that expression, 2x squared times y. Okay, so now looking at the next example, they actually ask us to factor this one. So we can find the common factor first and then factor it out. Now if we look at each term, we've got a 7, a 14, and a 21. So the number that goes in evenly to each of those is 7. So we could factor out a 7. Then if we look at the r's, we've got r to the 4th, r to the 5th, and oh, the r is missing here. So I think there's a typo. There should be an r in there. So then we have r to the 7th. So we have r to the 4th, r to the 5th, r to the 7th. So we can take out at least r to the 4th from each term. Then if we look at the s's, we've got s to the 5th, s to the 6th, and s to the 4th. So we've got at least s to the 4th in each term, so we can factor that out. So 7r to the 4th, s to the 4th would be the greatest common factor for each term in our expression. So now if I take, and I'm just going to erase the markings on this so we can go back to a clean question. If I take 7r to the 4th, s to the 4th out of 7r to the 4th, s to the 5th, what I'm left with is just s. So now how I can check this, if I take my value out front and multiply it by this, I should get back to this right here. So 7r to the 4th, s to the 4th times s does give me this expression right here, or this part of the expression. Now my next term, I have negative or minus 14r to the 5th, s to the 6th. So I would have minus 2, because 7 times minus 2 gives me the negative 14. Then I have r, I pulled out r to the 4th, so I'd have r left. And then I'm factoring out s to the 4th, so I'd have s squared left. And then my last term, the plus 21, and that was supposed to be r to the 7th, s to the 4th. If I take a 7 out of that, I'm left with 3. And then if I take r to the 4th out of r to the 7th, I have r cubed. And then s to the 4th, if I pull that out, I have no s's left, so then I would be finished. Okay, so if we just continue to look at this one for 1 second, you should always check to see that your factoring has been done correctly. So if we take 7r to the 4th, s to the 4th, and times it by 7, we get 7r to the 4th, s to the 5th, which is what we have right here. And then we take 7r to the 4th, s to the 4th, and times it by negative 2rs squared. So that gives us negative 14r to the 5th, s to the 6th, which is what we have here. And then the last term, if we multiply the 7r to the 4th, s to the 4th, times 3s cubed, we have plus 21r to the 7th, and s to the 4th, which is what we have right here. So then we know that we have factored this correctly. Now, another method for factoring is to actually use division. So I'm just going to erase some of the markings here. I'll put that R back on, that's our typo. So there should be an R in there. Now I'm just going to get rid of the work from the other question. Now, if you take the expression that we have and divide it by the greatest common factor, so if we take this whole thing and then divide it by 7r to the fourth, s to the fourth, and I'm just going to write that over here, 7r to the fourth, s to the fourth, and you should remember this from grade 9. We want to divide this into each term on top. So when we take 7r4 S5 and divide it by 7r4 S4, we're left with just S. And then if we take the middle term, the negative 14r to the fifth S to the sixth, and divide it by 7r4 S4, you're left with negative 2r S squared. And then the last one, 21r to the seventh S to the fourth, divided by S r to the fourth S to the fourth, you would have plus 3r cubed, and then the s's cancel off. Now you have to make sure, though, that you write what you factored out in front. Otherwise, you wouldn't get back to what you originally started with. But you can do it that way as well and get the same answer.